this. So just think, this is a complete iron rod and I use a coil here that which goes over that glass cylinder like this. Comes through the bottom, again goes like this. Is that right? We have wounded it outside that glass cylinder. Is that right?
Yeah.
So if I connect this side with positive and the other side with negative, will current flow through that coil?
Yeah.
And it will flow in this direction. Is that right? And going down from the other side. Is that right?
Yeah.
So, placing your right hand, curl of right hand finger in the direction of the curl of the current, where is your thumb pointing? Is it pointing that way?
Yes.
So this will be the North Pole and this will be the South Pole.
Okay.
Is that right?
Yeah.
Okay, now look. I break that and I show something to you. That instead of using a single rod, I uses two pieces of rod. I have actually cut that tube and I'm showing you that from the two halves. Is that right? So that rod from one side, from the north side going in, that rod from the north side going in. So it will be the North Pole. Is that right?
Okay.
It will be one kind of pole. Is that right?
Yeah.
If this is the north, then one side, actually that is not discussed in that detail, but the other end, what will be the other end of that pole? That will be the south.
South.
Is that right?
Yeah.
And I uses another rod here. So we know that that side, I need to actually cut it the other side also into two halves. So if I cut it into half, that glass tube looks like this. Is that right?
Yeah.
So what happened? This will be the South Pole. So if this is the South Pole, what will be the other pole of this rod?
North.
North. They will be magnet. These two rods, iron rod or ferrous rod, are magnet as long as current passing through that coil. Is it right?
Yeah.
So actually they are fixed at this and this position, but as they become magnetized, will not they attract each other because they are the opposite pole?
Yeah.
So they get connected. So as they get connected, what happens? Circuit gets complete. Current can flow through it.
Okay.
Is that right?
Yeah.
But actually what has been happened? They have turned, they have to bend a little because the other end are fixed. Is that right? So actually they have to bend like this and this because the other end are fixed. So this and this point is fixed.
The black points are
Just
fixed?
That's right. So actually as they attract each other, so they bend like this. Normally they should be straight.
Okay.
Is that right?
Yeah.
But they bend only when they get magnetized because opposite pole attract each other. Is that right?
Yeah.
And they are magnetized only as long as current passes through the outer coil. If you turn off the current in the outer coil, will these two rods remain magnetic?
Is this the outer coil? This one?
There is only one coil, the brown coil.
Oh, okay.
So if you stop the current, will these two rods inside that glass tube remain magnetic?
No.
That's right. So will they keep attracting each other?
No.
So they go back because they bend only because of the attractive forces.
Okay.
So they disconnected again. So no more connecting, no more current can flow. Is that right?
Yeah.
But you again turn on the current in the coil, they will become magnetized, they will attract each other again, and circuit get complete. Is that right?
Yeah.
So that what it says, one such switch is shown in the figure. When current flows in the coil, the magnetic field produced magnetizes these strips. They call these strips as reeds. Okay?
Which strips? Oh, okay.
The two strips.
Okay.
Got it?
Yeah, yeah.
So these strips are reeds. So when they get magnetized, inside the glass tube, the end become opposite pole, and we have discussed that. Can you see that little small N and S written in the center?
Yeah.
That. So they get oppositely pole on each other. Is that right?
Yeah.
So these opposite pole then attract each other and complete the circuit. Is that right?
Yeah.
And soon as you switch off the current in the coil, the reeds separate because there is no more attraction. They are no more magnetized, there is no more attraction, so it gets disconnected again. Got it?
Yeah.
Okay, so is there any other question from the reed switches?
No.